This is the Art of Network Engineering podcast. In this podcast, we'll explore tools, technologies, and talented people. We aim to bring you information that will expand your skill sets and toolbox and share the stories of fellow network engineers.
Hey, A1 fans, this is Andy Lapteff, and I'm here with Dan Howdy Packet Richards. Hi, Dan.
Hey, Andy, how you doing?
Howdy. I'm good.
Howdy.
Good to see you. So we are here tonight with Mike Pennacchi from NetAlly. Hi, Mike. How you doing?
Good. How are you?
I am awesome. So before we got on here, guys, we were talking about, how do you know your network is functioning as designed, right? Like I build it, it's running, everybody should be happy. Everybody should be fine. It's doing what it do, right? And, we often take a lot of things for granted, is Ethernet working? I don't know. You plug it in, it just works, right? When it doesn't work, how do you get to the root of the problem, right? Like, Dan, we manage networks. Okay, somebody's reporting an issue, right? Like, well, my NMS isn't lighting up. Everything appears to be fine, right? It's working. It should be fine. So, how do you get to the root cause, right? What's going on? So that's why we have Mike on tonight. Mike's a content creator at NetAlly. He is their guru, content creator, trainer of all things. So, Mike, tell us a little bit about yourself. What do you do at NetAlly? Who are you?
Well, for the last 25 years, I've been traveling around the world teaching people how to troubleshoot networks and getting to the root of network problems. I've been an instructor at Interop. In fact, that was where I started clear back in 95, was as an attendee. I was sitting there in the crowd. I had been a network administrator for a truck company here in the Seattle area, and we were having problems, and I was there to figure out, how do I get to the root of these problems? And I listened to a couple of guys that were talking about capturing packets and doing packet sniffing and everything, and I was hooked. And so I quit my job. I went down to California, worked for this company for about 5 years, came back up here to Seattle, started my own company, and I've had the luck of working with some of the best companies out there when it comes to doing network analysis and network troubleshooting. And so I've had an opportunity to help make suggestions on how they can make their products better and get to teach people how to use those products and then use them myself to go in and solve problems. So that's, kind of what I've been doing for the last 25 years.
You're a brave guy. You quit your job. You started your own company. You're my hero.
Well, I don't know if brave was the right. It was
courageous.
Yeah, and I found out with that one, that was really a sink or swim. And I had about 6 months to make it work. And again, fortunately with companies like Fluke Networks, NetAlly, and so on, they've been good to me and made sure that I've had plenty of equipment to train on, like the EtherScope we're going to be looking at today.
Yeah, I see all of the the devices behind you. You've got a plethora of testing devices.
It's beautiful.
Absolutely.
25 years in the industry. I could have used you 10 years ago when I started out sitting in a knock, when troubleshooting was my job all day, every day, and I had no idea what I was doing. Where the hell were you, Mike?
Oh, I was probably in Thailand or something, doing some training classes.
Wow.
But, and I'll tell you what's funny with networking, because, we're going to be talking about Ethernet today, is, as I traveled around, I had this whole collection of power cords and everything I'd carry with me. But the funny thing was, no matter where you go, there's an RJ45, and it's Ethernet. And so it's interesting to see, whether it's 50 hertz, 220, 110, whatever it takes. All of those things were developed separately. But the neat thing with technologies such as Ethernet is we're all working with exactly the same thing. So no matter where you go in the world, if you plug into it, it's either going to work or it's not, but it's going to be the same everywhere you go.
That's a good way to think about that, actually.
Thank goodness for standards. What was before Ethernet?
Yes.
Was it like Token Ring? What were you poor people working with before Ethernet?
Oh, that's, and that's where I still have some token ring equipment. And, and I kind of joke that I've forgotten, the things I've been allowed to forget, like standby monitor, token ring timers, plugging a 4 meg token ring device into a 16 meg token ring and taking it down. I don't have to worry about that stuff anymore. So yeah, it's kind of nice being in an Ethernet world and not having to worry about FIDI and token ring and all those fun things.
So I don't know how, I don't know how quickly we want to jump in here, but I'm looking forward to seeing the EtherScope NXG and what it does. And I guess the reason being is just for a little context for my history. I did, sit at a NOC for a couple of years, and, things were breaking all the time, right? And not even, when they broke, that was easy. My NMS system would light up, something was down, great, I can go take action. But there were a lot more subtle issues that would be reported. I worked at a national ISP, and people were traversing the backbone, and somebody would report, hey, this isn't, we had SLAs with all these customers, right? And somebody would call into the NOC and say, hey, we're not getting our SLA, right? And we look at our SLA tool and I'm like, well, the light's green. I mean, it says we're good. And, and these were big, multi-billion-dollar companies that were calling in, a lot of telco companies. So, what would I do, right? I'd start looking at some logs and some interfaces, and I'm looking for like errors on the interfaces or buffers filling up, like all the things that we think of to check. How are my light levels? Like, what can I possibly check? And I would just go end to end and try to check all that stuff. And the only way I could prove that the network was functioning the way it was supposed to was when we would dispatch techs, end to end with, piece of NetAlly equipment, an EtherScope, and they'd plug in both sides, and the only thing that got those people off our backs, or at least gave us an answer on whether there was a problem or not, is your devices would run that RFC test. The 2544, and yep. So I don't know if you want to briefly just tell people what that is and what it proves and why it's so important, at least in a service provider environment. It's the only way I could prove the network was good or wasn't.
Well, and that was doing a throughput test, right? So the RFC 2544 did a series of tests where packets were shoved into one end of the network and they came out the other. And we knew how many we put in, we counted how many came out, and we were able to tell whether the network was doing what it was supposed to do. And that's, there's two things that, I really try and emphasize. And, when we were getting ready for this, I talked about the S word, and that should. Mm-hmm. People will say, it should do this, it should do that. We should be getting 10 gig out of that. But unless we have a way to really measure that, it makes it difficult. And even if we're using software-based tools, and I think that's one of the big things that we see with tools like the EtherScope and the Link Runner 10 gig that we may have time to look at today, is these are capable of transmitting at full line rate. So there's no, guessing it. Did I have a machine with a big enough CPU or a NIC that's going to support that?
Yeah.
The other thing I learned over the years, when I lived up by Yosemite for about 5 years, and I had the chance to be on a volunteer fire department up there. And driving a fire truck has to be one of the top things. The first time I got to drive a fire truck to a car accident or something, that was pretty cool. But what I learned really quickly was people love firefighters. And we would show up and we'd grab a 2.5-inch hose line and start dumping 250 gallons a minute into somebody's living room, and they're cheering us on. And then if we were doing fire inspections, we'd show up and people hated us. People hate the fire marshal, right? Even me, when I had my building inspected, he goes, "Are you going to put anything under these stairs, like lead acid batteries?" I said, "No." And then later on, because I knew him, I said, "So Dave, why, how much?" He goes, "Well, more than 55 gallons. Oh, no." So even I found myself, telling him I was going to put some UPSs under there, but telling him I wasn't going to because I didn't want him telling me I shouldn't do that. So the reason I bring that up is people love somebody that's going to come in and solve the problem after the house is already on fire. What we don't like is the person that's going to come in and test it ahead of time and make sure that things are working. And so that's where network validation comes in. And so what I've found in my career is the more validation we can do at the beginning, the less likely we are to have to put that fire out later on. But a piece of that is, what do we expect? What do I expect when I connect up? And so I think that's where, when we start taking a look at the auto test feature on the EtherScope, we can go in and start setting some parameters, or it sets some parameters for us to allow us to go in there and say, is this meeting those expectations we have?
And you can fill up that pipe, right? You can stress out that connection.
Oh yeah.
Yeah. See, that's what's key, right? Because again, not to make this about Andy's knock life, but it's just so relevant to talking to you. We had an SLA tool, and it was saying there was a problem, but everything I looked at was fine, and I reported it up, and everybody's like, "Well, the phone isn't ringing. We're fine." And long story short, it was cell backhaul, right? So one day there was like a Daytona 500 race somewhere, and they were going to put out 50 cals. They were like these remote cell tower things that they put around the track, right? But they were all riding this backbone, this connection that that I helped manage. So the SLA tool was telling us for months there was a problem, but it seemed fine. Well, when they fired up 50 cell towers to this thing and did their tests, they're like, "Yo, guys, we got a problem," because we hadn't stressed it, right? And we didn't have the capability or the equipment to fill up that pipe to stress that gear. And again, with your equipment, we ran that end-to-end test, and whoopsie. And, long and short of it, found a bad line card in a chassis, swapped it out, and everything was fine. But it seemed like we couldn't prove a lot of the small, it's an issue small until it's not, right? Like, we're losing packets every once in a while. There's a couple errors incrementing, but everything's fine. Nobody's calling. But, you go to utilize that bandwidth, that pipe. And, when you push it, that's when you see problems. So I can't say enough good things about that gear you guys have and the tests you can run, because it's the only thing I could do. I mean, I just wanted to run an RFC test on everything everybody ever called about because it was the only way I knew,
Well, and that's, when I buy switches, like, I wanted to find the cheapest switch I could find that supported port mirroring for doing packet capture. So I bought this little $25 switch off of eBay. And what's the first thing I do? I do a throughput test on it, right? Is that switch capable of doing that? Because that's the first thing somebody will say is, well, yeah, $25, that's not going to do full line rate gig. It does. Wow. And, most oftentimes it does. But if we can test it easily, why not validate that and make sure that it actually does what we expect it to do?
So, Mike, we take Ethernet working for granted. So where do we start when it doesn't work?
Well, I'll tell you what. Let's jump over here. Here's our EtherScope. Ooh. So let me show you what we're talking about. And so we've got our EtherScope NXG. It's an Android platform. So it's running on Android. But what NetAlly did is they took and added all of these additional interfaces. So we'll move this back up here, and we'll switch over to that one. So here we see that on top of the EtherScope, we've got a 1 gig / 10 gig SFP slot, and we've got a copper port that supports 10, 100, 1000, 2.5, 5, and 10 gig, plus it'll pull up to 71 watts of PoE. So we can go in and validate PoE's working as well.
Wow.
So what that does is that allows us to go in and see, is that working like we expect it to? So if I flip over here to we'll jump over to the home screen of the EtherScope NXG. So when I start this up, if you've used an Android device, pretty familiar interface, right? We don't have to learn an extra interface. And one of the things that has been a great advantage for NetAlly when it comes to doing the Android platform is they're not having to write a lot of the basic things. They don't have to write a web browser. They don't have to write something if you have an embedded system. We can use that. And in fact, just as a little side note, we've got this app store right here. So there are hundreds of apps out there in the app store that we can load up onto the EtherScope. So these have all been vetted by NetAlly. So if I want to, like I've got a, it's a little Epson battery-powered label printer that will connect to this via Bluetooth. So I can load the Epson software on here, and I can print labels right from my EtherScope.
Nice.
Right?
Okay, so are these actual Android apps then at this point? Okay, okay.
Yeah. And in fact, if you have let's say you have an APK that you want to install, you can request that be put into Link Live, and you can even install custom APKs in there. Okay. And so if it runs on Android, it will pretty much run on here. So now we have all these different apps. So the neat thing is, and back to what Andy was talking about, the doing the RFC test, we've got a couple in here. We've got a performance test that we can do where we're going to do a throughput test, and we can set service levels in there to say, here's our packet loss, here's our latency, et cetera. Our jitter, if we're deploying voice over IP. The other one that they added is LANBERT. And this one is a pretty new addition. And what LANBERT does is allows us to put a device at each end of a piece of copper or fiber and just blast traffic through it. So I mentioned this supports 2.5 and 5 gig. So as access points are going up in data rate, our cabling needs to keep up. So you may have an organization that's got some Cat5e in there, and they need more than gig, but they need less than 10 gig. So that's where we get into NBASE-T, and we get 2.5 and 5 gig. Well, how do I know that cable that I'm going to put that AP on will support that? So what I can do is I can put EtherScope on one end and a Link Runner 10 gig on the other. I could do a 5 gigabit per second test through there, and I could validate that cable, as it's installed right there, will support that data rate.
Gotcha.
Then I can feel confident. So really the first place we want to start is if I come up here to auto test. Now, right now I've got an auto test set up that doesn't have any VLAN tagging on it, and it is going to request PoE from the switch. So I can hit start. Now, here's another thing, you were talking about a network management system out there monitoring. One of the challenges that we've seen oftentimes with network management systems is you're looking at things from a central point. And oftentimes, that network management system is sitting in the same data center as the servers you're monitoring. And so you are monitoring servers that are right there. You're not looking at it from the end user perspective. So tools like the EtherScope are specifically designed to be sent out to that far end. In fact, I'm driving it through VNC locally right now, but through Link Live, I can remotely control this. So one of the things that we've done is we've shipped these out to people. They've connected it to the hotspot on their phone or Wi-Fi network, and now we can remote in. So we're looking right over their shoulder, and I don't have to get on an airplane and try and fly out there to be there the next day, because I can get the EtherScope there a lot faster.
Wow. Really smart.
So in this case, when I come in here and look at the EtherScope, one of the first things that I look for when it comes to Ethernet is what speed did I connect at? So this tells me that the switch I'm connected to supports 10, 100, and gig, and I connected at gig. Now, to get connected at gig, we have to have all 4 pairs, because we're transmitting and receiving on all 4 pairs in that cable. So one of the things that we've run into in the past is we'll connect at 100. And that could be because there's a problem with pair 4.5 or 7.8 that's not letting us do full line rate gig. But the fast link pulse from that switch is still telling us, I can do gig. So the EtherScope will help us identify. In fact, that link will turn yellow if it sees that the switch is advertising it can do gig, and we negotiate any other speed other than that.
Is that what the actual speed would be? So like in your example
Yes.
there, it could show 10 meg, 100 meg, and a gig. But if it says actual speed at 100 meg, then you know that there might be something wrong with the pair in there.
Exactly.
Okay.
And one that we still run into, in fact, I've joked I could quit. I'll retire when I don't run into duplex problems anymore. There was this, back in 98, right around there were some ambiguities in the spec. And there are people that still out there thinking, we need to force this to 100 full. And what's interesting is when we do that, we're going to see that we connected 100 half duplex. You go, well, wait a second. Why is it connecting at 100 half if the switch is set to 100 full? And that's because the switch stops sending the fast link pulse. It doesn't advertise anymore because it knows what it's doing. So in that case, the device at the far end goes, I can hear you're doing 100, but I don't know what duplex you're doing. So it goes running over and looks up the IEEE spec, goes to paragraph 28, clause G, and it says, oh, I have to go to half duplex, and then you end up with a duplex mismatch. So that's the other thing is if I see that this is connecting at 100 half, that's a good indication. I usually talk to the network administrator and say, hey, is this forced for some reason? Oh yeah, we had something in there that, some legacy thing. Can you set it back to auto and it'll connect right up a gig? But now I've got a good idea of, what my speed and duplex is. Now, in addition to that, with so much equipment using PoE, in fact, I got the coolest, we were doing a webcast with our switch company with D-Link with NetAlly, and we were talking about PoE, and they've got some pretty cool PoE switches. And so one of the things that we were testing was 90 watt PoE. Well, it's hard to find any devices that'll draw 90 watts. So what I found was a PoE splitter that would split it out to 12 volts, 4.5 amps. It was actually kind of cool. So what I did was I used all this equipment back here as a load bank.
Yeah.
With the charger, I said it's the world's most expensive load bank, but we were able to draw 71 watts of power out there at that end device. And so that's the other thing is as our power requirements go up, here I'm saying, look, I want class 4 power. I want 25 watts. So measuring the voltage isn't enough because what you notice is we've got our true power voltage here. What happened was not only did we measure the voltage, but we applied the resistance required to pull 25.5 watts. And if we can't get that, it's going to tell us you can't get that. And so what's interesting is like doing some measurements here, I use a lot of thin patch cords, 28 gauge patch cords. They work great. But one of my 15-foot thin patch cords has the same resistance, the same voltage drop as 113 feet of Cat 6A. So we see that as people start using these thin patch cords in there, that smaller conductor, more resistance, we see the voltage go down. And once we get to a certain point, then that's no good. So this is comparing that true power voltage with the limits that we see with Ethernet or with PoE. It says, hey, look, we drew the power and you're just not going to be able to run that out here.
So let me ask, did those little cables start getting hot when you pushed 10 gig through them? And
okay. So let's see if my microphone cable is long enough. I've gone to a wired mic these days. So one of the things I've got is this cable right here, which feels like tubing.
Okay.
So this is copper-cladded aluminum wire. And every once in a while we run into this because it's cheap. In fact, what some of these manufacturers will do, they'll put scrap metal or concrete in the bottom of the box to make it weigh enough. It feels like a box of regular cable. So I bought 1,000 feet of this off of Amazon. And I think whoever's packing goes, this guy's a total idiot for buying this. But what's really fun with it is we drew that 90 watts through here. And by drawing that much current through really crappy cable, we were able to see packet loss.
Oh, wow.
And when we get into the weeds on PoE, we find out that if the two conductors in a pair aren't closely matched in resistance, it'll cause problems with the transformers in the transmitter and receiver, and we start seeing packet loss. And what was fun was we were able to see that. Now, what I need to do is take this out and figure out how to wire this up to my TIG welder out there so that we can draw enough current through it to set it on fire or something. That's the TikTok video I need to do on that one or something.
Yeah.
So now, I mean, I can see right away, I've got the PoE that I expect. I've got the connection I expect. Now, the other one, before we move on past connection, and we'll switch over here. Let's try a different camera. There we go. So we'll switch over here. What I'm going to do is I'm going to unplug the Ethernet connection on that, and we're going to switch over to a fiber connection. We're going to plug that in there. I'm going to go ahead and hit start. I'm going to hit stop. We're going to go back. We're going to change our profile here. And this is the cool thing, is we can have this whole library of all these different profiles. And I'm going to say no PoE, because I don't care how much voltage we're running. We are not going to get PoE through that fiber. In fact, I got to tell you, one of the years that I was in Vegas doing a class, somebody said, I saw a chair sitting there, it's facing the wall, and I thought, we always say there's no dumb question, so wouldn't it be funny to just kind of mess with the crowd? So a buddy of mine, at the beginning of class, raised his hand and said, hey, are we going to talk about power over fiber? And I said, that's the stupidest question I've ever heard. I made him come sit in the chair, and he's facing the wall. And people are looking at each other like, I think he's really going to make that guy sit there and face the wall.
Nice.
But what we see is, in this case, we connected up. But now it tells us, hey, we connected a gig full duplex. But the SFP that is in there, and some of them do this better than others, is giving us information about that optical signal we're receiving.
Okay.
So down here, we see it says receive power. It fluctuates right around negative 6.2 decibel meters. Now, decibel meters is a measurement of optical signal strength. So what this is telling us is that we're receiving an optical signal strength of about negative 6.181 or 0.2. Now, the number I don't want to see is anything lower than negative 18. With most gigabit SFPs, if we start getting around negative 18, then we're going to start having connectivity problems. So one of the things, and James Kokoska did the previous session, one of the things I asked James if we could add in here, and it's always fun when I see things show up, is James said, I said, wouldn't it be fun to be able to set reference to zero that out? So now I can hit that, and now it shows the power difference.
Oh, okay.
Okay. So now if I come over, and let me grab a fiber patch here real quick, what I'm going to do is I'm going to move this over to the end. Let's switch over here. And we'll move up to the patch panel here. What I'm going to do is I'm going to move this over to the end of a 200 meter fiber connection. So we're going to plug that in there. We're going to plug this into the EtherScope, and then we're going to plug that in. So now I've just added 200 meters of fiber between these two. So we're going to go back. We're going to hit start. We'll see. We'll make sure that I've got that on the right connection there.
I thought you were going to overbend the fiber. Thanks for not doing that.
Oh,
you were going to start doing the
yeah.
radius thing. Like, no.
Oh, I've got a bunch of fiber that one of my customers gave me, and I did that one time, and so I had enough fiber I could break it. And it was one of those things where it just felt wrong.
Yeah.
Right? You're bending it. Wait,
Don't tell him
it's
anything.
like don't make me do this. So we see that we connected up, and we connected at gig. Hey, that's great. And now we can see what the difference is. So it says power difference is negative, or 0.71 dB. So we're seeing that we have a slightly higher difference, that we're losing some.
Yeah.
So we're seeing we're losing about 0.7 of a dB. And when it comes to decibels and power loss, 3 dB is half the signal. So if we lose 3 dB, we've lost half the signal. If we're at 6 dB, we're at a quarter the signal. So in this case, hey, that's pretty good. We're going through a couple hundred meters of fiber. We connected at gig. It's all good.
So let me ask, what if you saw some crazy number there? Like, what would you say? -18 is what you don't want to see, right? Yeah. Like, what could be causing that? Could that be like a bad transceiver or something like that? Could
be? Yeah, it could be. In fact, this Netgear switch I have, it's been great. But I noticed if I leave it on for months at a time, the transceiver started doing some funky things, and eventually all the lights will come on it, and I'll reboot it, and things are good again. We've seen transceivers go out, or the SFPs go out. Cleaning. I use click cleaners.
Okay.
And I kind of felt bad about not cleaning those. I am a huge, probably because I do training on fiber optics as well, but I'm a huge fan of cleaning. And I see even the patch cords that come out of bags that are new, that have dust caps on them. You should be cleaning everything anytime it comes to fiber, cleaning it before you plug it in, because those fiber links tend to stay there for a very long time.
That's actually a good point that you brought up, because I was doing a change window the other night, and we removed the original coppers that we had plugged in, and this was across all of our edge devices. And so it was about 4 or 5 coppers that we unplugged, and I got a little sentimental, because it was like, there's no telling how many terabytes of information has gone over those simple 4 copper cables. And what's crazy is, like, how much did that cost? Just the copper cables, right? It just very little compared to how important the role that they had. And so when you talk about this, it at first it's kind of like, oh, come on, it'll be okay. But then it's like, this is a critical point between 2 critical devices. Like, how much money is spent on core devices that are fiber, connected through fiber, or or uplinks to your core and whatnot. And it's like, so taking that extra step, I think that is significant, right?
It is. And then things to take into consideration is, like, okay, so we're at -6. Okay, now if I come back here and I grab a fiber optic tap, so now I want to throw an analyzer in line. I want to do some packet capture. Well, we're splitting the light in half. So that is 3 dB of loss. So if we throw this in line, that's going to cut that down to 9 decibel meters at best. And so as a result, we're getting a lot closer to 18. So if we were already getting close to 18 and somebody throws a monitoring device in that shouldn't have made any difference, then we start running into issues. And so being able to check things like this, and maybe you don't have a optical loss test set, an OLTS device for measuring optical loss on your network. But a good start is measure the light right at the switch, go to the far end, measure the light at the far end, and with the ability to come in here and set our reference, we're able to see. And let's see if we can. I know, I said I wouldn't do it.
Oh God, no! Don't do it. No, it's like nails on a chalkboard. Stop.
Yeah.
Damn,
so
make them stop.
If I start bending,
oh my God,
this fiber around, can I make that number go up?
You gotta stop. I'm an old cable
Not
guy.
too
You're
bad.
killing me.
Yeah.
And so that's where, we start running into things, I don't know about this fiber, but bend-in sensitive fiber that, we're going to end up breaking it before we can bend it far enough. I was doing some other testing. I took some Cat 5e and stretched it. I wrapped it around a tree out in front. My neighbors think I'm nuts anyhow. But I started pulling on this cable, and it was 49 feet or 46 when I started. I stretched it out to 49 feet before it broke, and it still passed.
Wow.
So it's amazing the abuse this stuff will take.
Yeah. I'm pretty sure I've
Not that
seen
I recommend.
network devices hanging from copper cables, so I believe it.
So once I've gotten connected, now, in this case, it's, I can see what VLANs are out there, because that's another one is, the S word should. Does it have these VLANs on it? Well, it should have these VLANs. So what this is doing is this is looking at the 802.1q VLAN tags, and it's telling me these are the VLANs that are present on this port. And so at least I can see, if I, like on mine, VLAN 100 goes straight to my Comcast router. So if I want to put something on that skips my entire network and just goes right out to the internet, I put it on VLAN 100.
Okay.
86 goes through my AT&T hotspot. So, I've got different VLANs for all the different things I want to do. And I know that this fiber port I'm connected to has all of them on there.
I gotcha. I'm assuming it's some kind of trunked port.
Yes, exactly.
So what's the packet count on the VLAN right there, though? Is that just showing you that you're getting data over that VLAN as well, or?
Exactly. So that's showing, since we did our auto test, how many frames we've seen with each one of those different VLAN tags.
Okay. Good deal.
Is it bad that I haven't segmented my traffic at all in my home? Dan, do you have VLANs in your home network?
Oh yeah.
Yeah, I'm doing it wrong.
I'm a big IoT guy. I've got everything, wired up. And so that's one of the things. Everything, VLAN 12 is my guest network. So if it's a light switch, I've got power strips that control the lights out here. If it's connected to that, it goes on VLAN 12.
Yeah, I just put all that crap on 2.4 gig wireless and call it a day.
No. What are you doing?
That's what I do.
Channel 3, right?
Oh gosh. All right.
Sorry, I digress.
No, you're good.
So, and so then, we go through, and one of my favorite ones here is, it shows me what switch I'm connected to. So it tells me I'm connected to Studio Switch 1, I'm connected to Gig 9. And when we run this, like every time I hit that, I'm getting an email. And that email is telling me, hey, this test completed, the results were uploaded here. So I'm able to see where I'm connected. I've crawled under enough desks, and it's always that person that's got the solid back on their desk. It's jammed up against the wall. You can't see the wall plate. And then you go into the wiring closet and you're tugging on cables and stuff. Or, I was in one wiring closet where it got so hot, all the labels fell off of the switches. Man. And so they're like, yeah, we could Telnet in or SSH in, but we don't know what the IP address. We'll go get the console cable. It's like, not the console cable. And so I will plug this in, and I can see, hey, the switch is 10.0.11.12. So it makes it real easy just to remote into that then and see what's going on.
That's nice. I like that.
Hey A1 fans, AJ here for NetAlly. Never heard of NetAlly? Sure you have. They came from the same group of engineers that brought us network tools from Fluke Networks, NetScout, and now they're NetAlly. They know networking. I'm a network engineer for a partner, and when I go to customers and see they use NetAlly, I know it's going to be so much easier to troubleshoot issues we might run into. The name may have changed to NetAlly, but the way they build tools hasn't changed a bit. They ask, what would a network engineer want to help make their job faster and easier, and then they go build it, just like this EtherScope NXG. NetAlly is here to help. NetAlly, simplicity, visibility, collaboration. Visit netally.com today. Now back to the show.
It looks like it's using CDP right there too.
It is. So it'll work with CDP. It'll work with LLDP. Okay. It'll even work with SNMP. And that's the other thing that's pretty nifty about this is that we've been going in and doing the Ethernet piece, but after it got an IP address, it started doing a discovery. And it goes out, it discovers all the switches, it gets the bridge forwarding tables off of those, it puts all that together. So I can come in, and here, I got to show you this, because I think when it comes to network and why things might be slow, if I come in here to my path analysis, and I don't know, we'll choose whatever this IP address is here, and I'm going to hit start. And so what we're doing is we're tracing a path, and we're using TCP frames using port 25. And so what it does is it shows that we came out of our EtherScope NXG at 1 gig. We came into the switch here on my desk on port 9 at 1 gig, out on port 1 at 1 gig. We went into the studio core here at 1 gig. We went out at 1 gig. We went into our primary router on Ethernet or Ether 4 and went out on Ether 8, and then we hit the internet.
Oh, wow.
And I've run into this before where we did this path analysis and one of the links was 100. And it turned out that a cable was bad or something like that, and ping's never going to show us that. So by going in and getting all the bridge forwarding information, not only at layer 3, but at layer 2, I can see exactly how my network is connected together and follow that path through there.
Yeah, that's awesome. Because if you have if you have like daisy link switches and everything, and you're trying to figure out how to get back, how it gets back, wow, that's really cool. Instead of having to sit there and walk the network, MAC addresses and all that, and see where it's going. But that's pretty neat.
And that's where spending the money on managed switches is so important. If we're ever going to use a tool like this, spending the extra few dollars to get a switch that supports SNMP, because once we have that, now I can see how things are connected. If I don't have managed switches, if I'm buying the $25 switch, I can't do this because the switch can't, give me this information about where things are connected.
Gotcha.
So typically, if I walk in and plug this in, I'll know more about somebody's network than they do, right? And what's really neat is, if I come up here, let's go back. Click on the right button. I can take, right there, I can upload this to Link Live. So I can take this path analysis and upload it, and now I can use that for troubleshooting, or I can go back and assign it to a problem ticket and say, it's taken the wrong path.
Yeah. I got you. And you've mentioned Link Live a few times. We talked about Link Live in the last video, but just a brief overview. What is Link Live?
So Link Live is a cloud-based results management system. So when I get a NetAlly tool, the first thing I want to do is claim it to Link Live, and Link Live is free. And so what that allows me to do is take and upload those test results to Link Live each time I run a test. So now I'm validating and also I'm documenting. So what I can do is I could come back here to my auto test, and let's go back here. Down here I can click on this little plus, and I could say I want to add a comment. And so I could type in the jack number. I could say 20AL.B01A. So I could give it a jack number, and then I can upload that. And what it does is it saves that to that test result. So later on, I could go back into Link Live and I could search for 20ALB01A, and it will say when we did this, it was connected to that switch port. Hang on. Alexa, it's time for class. So
nice.
I forgot that I had a timer because I forget to turn the lights on out here all the time.
Yeah.
So at 7 p.m., the lights turn off. So there we go.
That's awesome, dude.
Your home is smart.
Yeah.
Sometimes too smart for it. Like now, a little too smart for me. But so, we can Yeah.
Gotcha.
Fun stuff.
Yeah.
So I'll tell you what, let me show you one real quick here because the whole throughput thing had come up. So what I did was I grabbed, let's go back here, and I grabbed the Link Runner 10G. So the Link Runner 10G is basically an EtherScope NXG without wireless.
Okay.
So the EtherScope NXG does wired, it does wireless, it does all that fun stuff. So with the Link Runner 10G, this is wired only. So what I'm going to do is, we had a question come up recently about thin Ethernet cables. And are they, short thin Ethernet cables specifically? Can they be problematic? So what we're going to do is we're going to take and connect the Link Runner 10G to one end of a 295-foot cable run. So that is the maximum permanent length that we would ever have in a wall. I'm going to grab this little 1-foot patch cord right here. I'm going to plug that into my EtherScope NXG. And then we're going to come over into the EtherScope, and it's going to try and do an auto test. But that's not really what we want to do because there's no DHCP server and so on. So I'm going to go back, and I'm going to go into LANBERT. So LANBERT is the tool I can use for testing just a copper or fiber link. I want to make sure this link is going to support the speed I want. So I'm going to put the Link Runner 10G into loopback mode. So it's going to listen for a connection. Let me make sure I got it in loopback. And I'm going to start it. Then I've got the EtherScope NXG in generator. So I'm going to come up here and hit start. So what it's going to do is it's going to try and link to that Link Runner 10 gig at the other end. So we linked at 10 gigabits per second. So now we're going to start jamming bits through that cable. We're doing this at full line rate, full duplex 10 gig. So there it is not giving any mercy to this cable. It is shooting this traffic through at full line rate 10 gig. We see that we're at 340 million frames so far.
Slam it.
And we've seen 0 errored and no lost.
And this is the 200 and what did you say, 290 something foot?
Yeah. So we're going through 295 feet of Cat 6A cable that would be in the wall. And we've got the short patch cord on one end and the long patch cord on the other.
Okay.
So, well, long, it's about a 5 foot, but they're the thin patch cords. So if somebody says, are thin patch cords any good? Well, I can tell you that these mono price thin patch cords that I got off of Amazon that won't pass a Cat 6A test will move 10 gigabits per second full duplex through without any problem. In fact, we've completed our test. We sent almost 1 billion packets in each direction, and we didn't lose any.
Wow. Now, so why do they not pass that test then?
A lot of it has to do with near-end crosstalk and the design of the connectors. And one of the things that we run into with RJ45 connectors is that we've got pair 4-5 in the center, and we've got 3-6 that go right on each side of it. And the way that those are laid into the connectors can cause crosstalk. So what we find is that when we get into Cat 6A, a lot of times we start using what are known as field-terminated connectors. And they're like these toolless connectors where we lay the pairs in there, and inside that connector, those conductors are run in such a way to reduce that crosstalk. But we kind of think of, like, if there's a bridge and it says this bridge is, capable of having carrying 25 tons. All right, so anything weighing less than 25 tons can cross the bridge. But I've got a 94 Suburban I pull my dump trailer around with. That weighs about 9,600 pounds empty. So if I drive that across it, it's like, well, that bridge is good enough for my Suburban and trailer. So what we're finding is Cat 6A would cover speeds beyond just 10 gig. So, my thing when I ask people is, what is it you really want to do with it? So in this case, we can say, hey, we really want to do 10 gig.
Yeah.
Or if I'm validating a link to do 5 gig, I can run 5 gig across.
Yeah, and you can just beat it up with this and spit out what your loss rate is and all that. Nice.
Exactly.
I like that.
And we can come in our settings, and we can say, what is our threshold?
Okay.
And, it's like with VoIP, we have jitter. And every VoIP provider will tell you this is how much jitter they can handle, packet loss and latency. So I was at one location, I said, hey, what's your packet loss and jitter thresholds? And they said 0. I said, let me talk to somebody that actually knows what they're talking about, because it would never be 0. Right. And so it's one of those things where if I said I expect 0 packet loss on my network, that would be an unreasonable expectation, or I would be willing to spend massive amounts of money to make it work. James Kokoska, one of the things they found was any electrostatic discharge could cause a bit error here and there. So they bought an electrostatic discharge gun, which now I got to go look one up and see, sounds fun. But they could fire this thing around the room and you would see a few lost packets here and there. And that's that. But the whole design of Ethernet cabling is to help cancel that out. But we can only do that to a certain point. So if we set our threshold and said, hey, anything better than 0.01% loss is okay, then at least we have something that we can do a pass-fail test on.
You guys are having way too much fun walking around with static guns shooting Ethernet cables. Sounds like a fun job.
I got my hands on an oscilloscope, and we were hooked it up to an Ethernet cable. We had a fluorescent light. We were turning it off and on. You could see the spikes on there.
Yeah, that's cool. All right. So what was the last thing we looked at? We looked at the path analysis, and then we went into the Lambert generator. Let's see here. I think we're on point 1, 2, 3, 4, 5. I think we're on 0.5 right there. Where are we at some point?
So where are we? We talked about that a little bit with, here, let me move back over to the switch with the CDP and LLDP.
Yeah, that's it. Yep.
Right? So we're able to see where we're at. Can I get an address? And, that's the other thing. And now we're starting to move up the stack. So if we're really talking about Ethernet, now we're getting into IP and network layer and everything. But the neat thing here is that this shows me who gave me the IP address.
Gotcha.
Right? So I can see my MikroTik router gave me the address, lease time, offers, and this will tell me if I got 2 offers. So if I get some clown in my network that brings in a router from home and plugs it in, and it starts handing out 192, 168 zeros, this will show me that. And if I'm lucky, I can do a path analysis and find out where it's plugged in. And then I'll just disable their port.
Yeah.
I don't go out there. Some cases I've gotten to walk around network administrators and just take stuff. But they go, but that's mine. It's like, you plugged it into our network, and we need to make sure it doesn't ever come back here.
I guess something else it could show you too is like if you're doing a split scope on a Microsoft server or something like that, it could tell you which one you're actually on, right?
Yes, and it could tell us which server's handing out the address.
Okay.
Right? So we can see that. We can see, if we're using DHCP relay, which of the routers grabbed it and forwarded it on to the server. So it gives us some good insight into what's going on. And here we see that our offer came back in 4 milliseconds. So we can see that DHCP server is responding in a timely manner.
Yeah, and You were talking about thresholds earlier. Can you do thresholds on the DHCP, or does it have its automatic threshold that it says, hey, this is bad, basically?
If it takes more than 60 seconds, then it fails.
Okay, I gotcha.
But the other one on DHCP is I can change the MAC address on the EtherScope. So back to the S word. Let's say that, I don't like people configuring static addresses on devices. I prefer to put in DHCP reservations, so that way I have a little more control over the network. But if I know their MAC address, I can put in the reservation. I can set the MAC address of the EtherScope to that MAC address and test to make sure it's getting the right IP.
Okay.
So especially we see like with hospitals where they're bringing medical equipment, maybe it's harder to see the address on it, or you've got a headless device. That way it's just one of those things, validation.
I was just about to say, going back to your validation point, you can test that and then hand off the network saying, hey, we're ready for you to plug this in. It will work, basically. Yeah.
Exactly. Because we tested it. We validated it.
And we have a report.
We have a report. DNS. Yeah, I got my little Raspberry Pi running DNS here. And so I can see, DNS is working. And I can see, how long did the lookup take? And so here it's showing me the top 3 DNS servers. And that's another one. I was at a facility. They said, yeah, we're having connectivity problems. And I ran this, and DNS server 2 wasn't responding. I said, tell me more about DNS server 2. Oh, we de-implemented that thing. I said, it's still in DHCP. Yeah. Next time, take it out of DHCP first. And then let's, de-implement the thing. So I can see, DNS is working. And then in this case, I've gotten to my primary router. So I got to, my office primary router, I ping it. It's going to go out there. It's going to make sure I can connect. If we have V6 running, it can give us a V6 address, see if we got a V6 address. And the other thing with this is now I can come in and I can do all those basic tests. I can tell it in my config to stop after a certain test. So if all I want to do is make sure I have connectivity, I don't want to have to wait for DHCP to fail. Because maybe my job is to put the switches in and the cabling, but I haven't. So I can say stop after link, stop after PoE, and it'll run the test. And the neat thing is, I could have my EtherScope connected to my hotspot through the management port, and it's uploading the test results, even if I'm connected to an isolated network or one that doesn't have internet connectivity.
Yeah, so like an example would be as if somebody was building out an office or a building or something like that, and you had techs on site that were running the cables and setting up switches, but maybe like uplinks and routers and firewalls and all that stuff hasn't been implemented yet. They're just getting the cable into the switches. Then you or whoever has this tool, you could be remote catching these reports that are coming up to be like, okay, they finished this switch, they finished that switch, they finished this floor, whatever, and have all your test results right there. That's really cool. I like that. It's flexible,
and then when it comes
right?
to exactly, and when it comes to the throughput tests, another one I'm big on is, if you put in redundant links, I go in and pull the main link. In fact, one of the years at Interop, I was a lead network engineer, and I would show how fast it would cut over, and I'd walk over and just grab the whole uplink for the show and unplug it, and you could see it switch over.
Okay.
And eventually the guy in charge of the whole show said, please stop doing that. Just scare us. But it's what I consider to be the flat spare tire syndrome. And that is people depend on these backup links, but they never test them. And so I remember my kid with his pickup truck, got a flat, and the spare tire was flat. Like, well, okay, whoever checks their spare tire. And it's one of those things where periodically, especially when we turn everything up to avoid the S word, we need to go in and check and make sure that redundant link is doing what we expect it to do.
Right. Yeah.
But what's neat in here is I can come in and I can add test targets. And so the EtherScope has a whole library. Every time I add a test target, it just puts it in this library. So I can go in and quickly assemble tests. So I could say, I want to test my email server on 465 and 993. So if I'm doing IMAP-S and SMTP-S, I can grab those. I can say I want to test going out to NetAlly and Google. So now when I run my auto test, go back and we'll rerun that. It is not only going to test the local connectivity, but it's going to actually go out to those sites and make sure that I can get that. So now I can create a profile for a office user. I could create a profile for a printer out on a production line. And if I know what their dependencies are, I can come in here, and the fact that I got this nice green link right there tells me I got to everything.
Gotcha. So is this kind of a use case where, like, let's say you spin up a site and let's say even you have like homegrown apps that you have back in your data center, right? You could run that in that profile.
Yeah,
that's awesome. And then
it's going to test the TCP port.
Yeah, right.
And one of the things that I'll do is I'll go into my firewall and block port 25, and we can see, port 25 will fail. So then we can do a path analysis on port 25, and it's doing basically a TCP trace route. So now it'll say, ooh, I only made it as far as your firewall.
Right.
So now I know about where that's blocked.
No, they're going to tell me it's the firewall, and they know it. That's really cool. So what is cool about this is, in the list right there, it seems like a simple list, right? But there's just so much in each one of those that it's just crazy that one device can kind of tell us all of this information. And I'm just, that's really cool to me. Like,
well, and what's funny is over the years, and look, I built a Arduino Christmas tree watering machine, system with an app. So I'm really good at making things complicated. But what I've found over the years is that I'll get people who'll say, well, I could do that. I could do the TCP part with TCP trace route, and I could do a ping, and I could do this. And it's like, okay, well, once we start getting to CDP, there's some Linux commands where maybe we can get that. But I challenge you on the PoE to, short of sticking your tongue on there or something, right? Tell me, is PoE doing what we expect? And the other part is, if you've used any command line tools, there's always like 5,000 command line parameters. So you have to remember all the parameters. What this tool has done is it's made it very easy for somebody to grab the tool, pick the profile, and go run the test. So if I, as a network engineer, go in and build the test and say, this is exactly what needs to be there for this to work, I can give it to virtually anybody and say, go run that test. And if you're not getting a green link up here, then tell me what's gone wrong. And probably, the last thing that I really want to show on here is that is one profile. So now I could come in here and say, you know what? Let's do VLAN 10. Let's do VLAN 14. And I know we're talking about Ethernet in here, but I could say, let's do PR Home 5G. And so now when I hit start, what it's going to do is it's going to go through each of these profiles. So it's going to test the no VLAN connectivity. It's going to test VLAN 10. So if I have phones, it's going to test VLAN 14, and it's going to connect to Wi-Fi. So in one push of a button, it is now going through and running all of these profiles that I've previously built that I've assembled into a unique view of where I'm at right now.
That's really awesome, because now, going back to my remote office example, you can test your like in here you're talking about your phones, your data VLAN, and then you can also test your wireless all in one test. That's crazy. So you could give this to like a remote tech or something, and or ship it, wherever you need to. Have them test, if let's say you have 20 sites, right? Like you could just have them go test all these sites and bring that back. If you're bringing on a new site, be like, hey, I want you to run this test as well. And then we can validate that, hey, this office is going to work like the other sites that are already established.
Yes.
Yeah, that's pretty cool. And you could do it in one test. That's what's wild.
And then the ability to remote into this means that if something fails, they can go, hey, this failed.
Yeah.
I was working with a group that was doing a wireless survey, and they took the AirCheck G2 out. They did the survey, they uploaded it, and I was able to see the Wi-Fi surveys within minutes of them completing. And they would call me after they completed each floor. Does that look good?
Mm-hmm.
Yes. Does that look good? So now I can come in and if we look at our wireless, we can see that, channel 149 is yellow. And so we could see that, we exceeded our utilization on that particular channel.
And is that the built-in threshold right there, or is that a custom?
Yes, and we can adjust those.
So like if you only want to be using 50% of something, it'll alert you when you've passed that threshold, right?
Yep.
Awesome.
So in this case, we couldn't get to my network attached storage, which I'm kind of curious about that. I got to go look at that one. That's not good. And this one's probably going to be the same thing. Yeah. So both of these, my NAS box is not responding.
Maybe Alexa turned it
powered off.
Yeah.
That teaches me to put a UPS on, right? If it runs long enough, it stops responding. So that's, and that's why it's the tool I bring with me, whether my brother-in-law recently said, hey, can you help me with, my wireless network? I can test the wired side. I can, I put in, when I had wired his house decades ago, I put in Cat 5e because that was the hottest thing at the time. So now I was able to upgrade his switches to gig, make sure that I got gig, did a little throughput test to know I was getting actual gig, and then plug the APs in and know everything was going to work.
Hey, I'm still running 5e. Take it easy.
It worked. I mean, we can get 10 gig out of some of it here. So.
Odd. All right, so let's see here. I think we hit all of those points on her notes there. Let's see here. Yep. Yeah, I think we did a good job on all that. How do you feel about that, Mike?
I feel great.
Okay.
Actually, I wrote that for her, so I feel.
You wrote that. Okay. So these are your notes.
Those are my notes for her. Yep. So yes, I feel that we absolutely got through everything that we wanted to cover.
Okay.
I'm sorry. You gave her notes. She gave them to us for when we talked to you.
Yeah.
Hey guys, can you make sure the notes that Mike gave you he touches on, please?
Make sure he really talks about this.
That's too funny, dude.
Mike, this has been fantastic. I mean, I started this conversation with you only knowing one thing that you folks did, which was that RFC test, because it's the only thing I ever ran into. And we talked here at length about, like Dan had framed it. It tests everything and anything you'd ever need or want to know about a network, and then some. Like, you guys you've thought of it all, right? So this has just been really informative, fantastic.
We jokingly called James the mad scientist of Colorado Springs. I mean, that guy, it is to sit in a meeting with him. I mean, his mind is just, it's going faster than he can say it. And one of the things that we see when we get into the wireless piece of this tool is that the MAC address is the same on the wired side as it is on the wireless side. So now we can start merging that together to figure out what APs a device is connected to. We can get IP addresses. We can figure out what the IP address of a wireless device is without even ever connecting to the wireless network. So it's the way that they have merged the data together is unlike any other tool I've ever worked with.
So when people watch this and say, holy crap, I need to get this, how do you recommend they get in touch? I mean, you're probably a busy guy. You don't want them reaching out to you. You know, usually we ask our people like, hey, how can people find you, right? And you're welcome to share that stuff if you want to be harassed by a bunch of nerds.
So, Casey, Dan Klimke could probably tell you better. It's, going out to the NetAlly website, finding a distributor, finding somebody that, is selling the product. I'd love to sell them, but that's the whole, I rather, it's always nice being somewhat independent.
Yeah.
In that, people say, really, is it that? Well, it is that good. I've been working with this thing for a long time, and it really is that good.
Gotcha. All right. So Andy, let's do a wrap up on this, and then we can stop.
I tried
recording.
to wrap twice, Dan. What else do you want me to say?
I think maybe what we should do is kind of get an overview, like where we started. We saw that we had the link, and then we got into, is it pulling power for PoE? And then it went down to showing what switch is it. And then it goes into, at that point, it started going into DHCP, right? Yeah.
Yep.
So let's just kind of highlight. And
that was my point of saying, wow, you guys thought of everything. There's nothing this thing doesn't test.
Yeah.
We spent an hour on a 30-minute piece here, and we've wrapped 3 times. I mean, I could try again if you want, but I think we've hammered the details to death. I mean, it's up to you, Mike. You've done this more than us. I can do a specific, wrap.
No, that sounds great. I mean, it really, I think that is, they have thought of everything.
Yeah.
They've thought of, all of those pieces that you need to look at to figure out, do you have the connectivity necessary to get your job done?
You guys have killed it. I mean, I wish I could think of something that, I'd love to be, I'm in product management. I'd love to be like, hey, you guys didn't think of this. You need to get this new feature. Like there's nothing you guys can't verify.
And I got to say, one of the cool things too is we can go in and add a picture. So this has, it has a camera built into it.
That's awesome.
Wow.
So we can say, can we access the camera? Oh, blah, 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 blah. So there's, there's the camera, right? And so it's, in fact, that's one where if I'm remoted into it and I want somebody to show me what they're looking at,
awesome.
I can just have them bring up the camera.
That is way too cool.
And go in and see what's on the camera. But we can take a picture, like if there's an AP up in the ceiling that, is covered up or something like that.
Hey y'all, this is Lexi. If you vibe with what you heard us talking about today, we'd love for you to subscribe to our podcast in your favorite podcatcher. Also, go ahead and hit that bell icon to make sure you're notified of all our future episodes right when they come out. If you want to hear what we're talking about when we're not on the podcast, you can totally follow us on Twitter and Instagram at Art of NetEng. That's Art of NetEng. You can also find a bunch more info about us and the podcast at artofnetworkengineering.com. Thanks for listening.